Welcome to the another session in Frontiers in CFD. So this is a reference geometry which we are following today. We have inlet and outlet. So accordingly, we have the cells which are been provided in between. So we're not going to prepare the exact one, but we'll do it for around 20 cells. And based upon that, we'll see how the fluid flow has been taking place and how heat transfer has been taking place. So we are going to use this geometry as a reference geometry for preparation of uh, the geometry which will be prepared for 5 cells in a single row. Accordingly, there will be 4 rows. For we are going to do it for 20, and we'll see how the simulation results are getting. So let's start with the workbench. So we'll use the fluid flow fluent. So first of all, let's prepare the geometry with the help of new design modeler. So we are trying to prepare the sketch, and then accordingly we'll proceed. So first of all, set the units to mm. This is ZX plane I will select over here, look at, and accordingly I will prepare the geometry. So for this we need to prepare sketch. So on ZX plane, click on sketch. So let's have this. From this we will start from the center. So let's take it around 110. So this is a sample we are taking. This one, with respect to this, we need the angle. So 60 should be this one. So let's take the dimension. I already taken 110. One more line we have to draw from this, so that will be horizontal line. So let's take it around 137 here. Then draw one more line which is going up parallel to the earlier line with the same dimension. We'll take as 110 and draw this in horizontal and join this. So this is how we have tried to draw first sketch. On this sketch we have tried to have a kind of arrangement. Now on this we are going to generate one more sketch here. Now we'll try to prepare the path of the particles. So accordingly we'll just put the first cells and as well as we say the path. We are in the sketch 2. Let's see the dimension of this. It will be 18. So let's draw one more circle. So somewhere here we have taken. So this is actually we are trying to first generate the path, and accordingly we'll proceed with the next part. So we have tried to generate first cylinder of 18, then another cylinder of diameter 28. So one by one now we'll proceed for creating the other circles and path. So let's proceed further in horizontal direction. So take dimension as equal to 23. Draw two circles. So one more line, it has to be drawn horizontal. Say this is 23. Then draw circles. So in one row we are trying to have 5 circles, so accordingly we'll prepare the 5. Let's make it 23. Draw circles. Yeah, so we have generated the 5. Now we'll try to draw a parallel line to this. So dimensions of this will be again 23 here. From that again we need to draw circles. Two circles. Similarly proceed with the horizontal here. So horizontal distance we are taking is 23. So parallel line you have to draw. Dimensions of that will be should be 23. So let's take it 23. So one more time, draw circles. Two circle we need to draw. Horizontal line. Again that should be 23. So draw two circles again. So now it's time to trim the object. So as to generate first a path, so I will go with the modify option here. So go with the trim operation. Okay, so one thing is also left, that we need all again few of the things in the this direction also. Okay, make sure that it is parallel. So let's make it 23 here also. Draw circles from this. So now let's do the trim operation. Whichever is not required, just you need to trim out. We are interested in this path only, so from this I will draw one line vertical. So whatever is not coming in the path, though that whatever is not required in the path, that will trim out unnecessary things here. Sorry, this one, this one, so one more thing is left, that is we need one more parallel line here, so that too again of dimensions 23. So make it 23 here, and again you have to draw some circles out there. So we are trimming all the things which are not required. This will also be used as a reference when we proceed for the next part, that is we need to generate the cells. So as of now, first we are creating the serpentine channel only, then remaining part will do. So going back to sketch 1 and then joining these two parts here. Yeah, so most of the things has been done. We'll take a quick look of the geometry because there should not be any errors in the geometry. Okay, so we need only serpentine channel path, so we'll trim out the unnecessary things which are required in between also. So here go with the modify, again we'll go with the trim operation available here. So in that case, as I said, we'll be just generating the path over here. So I will trim out unnecessary things which are in between. So once this path is generated, so whatever is there in between the path, so that we need to remove, and then it will be left only serpentine channel. So I think most of the things are actually been rendered. Okay, so these are the things which we need to slightly modify here. So this is the section has been trimmed out, so we need to complete this section here. Same way this section is to be trimmed with the this one. So now almost everything has been done, so let's go with the operation which is called as the extrude. So let's go with the extrude operation here. In that case we need to select the sketch 2. Okay, so sorry, just a minute. In sketch 2 we need to trim out few things. So this is not the part of sketch 2, this is also not part of sketch 2, it will be part of sketch 1. So here I will go with the sketch 1 and simply extend this part here. So just like to draw a line here from this point to this, similarly from this point to this. So we drawn some lines, so now the entire sketch will be complete. So click on ZX plane, say look at. Yeah, so this is how the channel we have prepared as of now. Now in this case we need to extrude the operation. Extrude, instead of add material I'll make it okay, just make it here sketch 2. Okay, just a minute. First we'll go with the sketch 1, make it apply. So depth is 65, make it here and generate. So this is the part which is generated. Now on this same part we'll do the slice operation with the help of sketch 2. So let's go with another extrude operation. Now select sketch 2, instead of add material I will make it slice material and generate. So you can see now here the things are generated on this solid. So the channel is actually been prepared. Now let's look at the plane again, and now it's time to generate the circles, or we can say the cylinders. So what I will do here is I will go with one more sketch, that is sketch 3. Click on circle. So we already have some circle center points, so with this center points we'll just draw a circle of radius that is equal to 18. So make it 18 here. When it is drawn, then you can draw the others. So say this is the point, so I will take it. Once you see R, you can stop there. R, let's see R. Okay, so all this are with respect to radius 18. Now what we will do is we will do operation which is called as again slice operation. So that is again extrude will take, sketch 3 will select, make it apply, instead of add material I will make it slice material, and it will be generated. So you can see now here the cylinders are also been generated. So look at each and every cylinder, how they are been having some interaction out there. So accordingly we'll have to prepare the next part. So this is outer part is actually unnecessary, so you can remove that as well. Now one thing which is left is we need to create a kind of fluid flow channel which has been taking place over here. So this is will be the fluid will be coming here and it is going on the other direction. So that is the last part we need to do. So this is the geometry which has been prepared. So one by one you can see the in between part also, this can also be easily deleted. So but before that we need to create this as a fluid zone which has been having interaction with the, we can say, the cell. So this also need to be with some diameter, with some internal thickness. So accordingly we are going to do that. So for this one more time I need to follow one more sketch. So go here, we'll create one more sketch here, and on the sketch again we need to go with one dimension that is equal to circle with diameter is equal to 23. So I need to draw a circle with diameter is equal to 23. So this is the circle with the diameter we are drawn as a 23. Similarly I need to draw few more circles on the similar note over here. By default when you see R it will be match. So let's go with the last part. So this has been missed, so again we will do the same operation here. In the sketch 2 somehow I think I had done the trim operation in between, so that it has not been visible over here. So what we can do is, again we can prepare a sketch on it. So what I will do, I will just trim out this thing which is over here, so that there will not be any error in the further geometry. So let's trim out this as of now, and let's generate the object. So this is how the object is generated as of now. Now I will do one thing, I will prepare one more sketch on this here. So this is sketch 5, and again I will click create a circle over here. So let's create a circle. So from the same point, it should be radius is equal to 18. So let's take the dimension that is equal to 18. So one more time, let's go with the extrude operation. Select sketch 5, make it apply. Instead of add material, I will make it slice material. So you can see it is generated. So in this way, this is how the things which we required. Now the entire object has been generated. We now need to make the internal part as a hollow, because the fluid is flowing through this. So for this again we go with we need to do is we need to prepare a sketch on this. So for this I will just go with one operation which is called as body delete operation. So I will delete the unnecessary things which are not required for us as of now. So this one, this, whatever the parts which are in between, so that we don't require, I will trim out. Sorry, I will delete this. Yeah, click on body delete and make it generate. So you can see now entire structure has been generated, which is like here. Now I need to make this as the hollow. So we need to make this as a hollow. So that's why what I need to do is I need to prepare sketch on this plane. So create new plane. I select from face, I will select. So this is the face which I am interested in. So click on the face. So this is the face which I am interested in. So let's make it apply and generate. So we have generated a face on this. On this face I will create a sketch over here. So I will take it slightly on one side so as to visualize it in better way. So on this plane 4, let's make it a sketch. Now while making the sketch, we need to draw a kind of rectangular arrangement here. So I will draw a rectangular here. Yeah, so let's take the dimensions of this rectangle. Here it is. So total we have 65. So out of that, if you take this is 62, so 1.5 and 1.5 will be left. So I take slightly zoom in, go inside. So what I need is I need the dimensions over here. So let's this is reference and this is your line. So this should be equal to 1.5. So both of side it will be equal then. Next thing is this is one reference line we have. From this reference line I need the distance here. So again, if you take total is 5. So out of that let's say if you take 1 on this side, remaining 1 will be on the other side. So take this one. So let's we take it 3. So what will happen, it will be 3 and the space here is 1. So on both sides it will be 1. So accordingly now we have prepared the kind of sketch. I will do one operation which is called as sweep. So for this I will select sketch here, and path I will select the earlier which we have generated. So I think it is sketch 4 is our path. Make it apply. Okay, just a minute, something is okay. Let's make it generate and go back to your sketch 4. Let's see if anything is left. Maybe something we haven't trim out. Okay, this is a part which is not trim, so we'll go with the trim operation here. Okay, now there will not be any error over here. So let's go back to your sweep again. Select your sketch 6. Path must be your sketch 4. Make it apply and make it slice material here. So you may create the thin surface, already we have created there. So you can see the channel through which the fluids are been flowing. So the fluid will flow from inlet to the outlet. So it will come from the inlet and it will go to the outlet. So accordingly, we are going to have such kind of geometry which has been here. And now let's once the geometry has been prepared, we will give the name selection at particular locations. So let's see one by one the object. Let's click on ZX plane, make it look at. So what is this one? This is your casing through which the fluid is been flowing. So you may either say channel also. So let's say this is channel through which the fluid is flowing. So this is cell. So one by one I will click and just check it here. So how many cells are there? Okay, there is one last. So I will form this as a new part. Let's denote this as a cell. Okay, this is our solid. It's actually a fluid which is fluid channel, so I will make it to fluid generate. Here you also need denote this as a fluid. So this is a channel, this is a fluid, and this is your cell. Now inside the cell I will rename all of them to, let us say, cell. So all of them I will rename to cell, so as to avoid any confusion when we do it for the post processor or we are in the mesh. So ensure that the cell portion should be solid, and this should be solid as I said. This should be fluid, you just check it here. Then channel, it should be again solid. So these things are done with we can say the channel and other thing. So we'll just save the work. I will take serpentine channel with 20 cells. So here also I will write so it is important to save the work so that we can access it later on. So let's open the mesh part. Okay, so we have the mesh here. Let's click on generate. So the default mesh will be generated. Depending on how good the mesh is, accordingly you may modify the mesh size as well as the element size which has been here. So this looks to be not that great because this is a channel through which the fluid has been flowing. So we definitely want comparatively finer mesh on this region. So what I will do here, I will just check the statistic here, only 54,989. I put it 0.01 as element size, and let's make it generate. Okay, it hasn't changed much for 0.01, so I will put it 0.01. So if it is taking more time, then probably you may reduce the mesh size, but now it's almost 61% is completed. So hoping that it will generate a quite better mesh. In addition that, you may either do the mesh sizing option, and that is also one option available on this channels. So that is one way of having a better mesh, especially in the region where the fluid has been flowing. Okay, so this looks to be quite better, even though I will not say it is too fine, but it looks to be quite better than what we had earlier. So it is around 13,48,187. So I'm going with the same mesh. I'm not going to further modify it or further making it fine. So I'm okay with this mesh. So accordingly, I will just put the inlet and outlet over here. So this is how the mesh has been generated. Let's denote the inlet and outlet. So I will put here as an inlet on this side. So select this one, make it create name selection. I put it inlet. Similarly on the other side I will put it outlet. So we have two things, one it is inlet and second one it is a outlet. Now apart from the channels, so let's see this, I will hide all other bodies. So this is the cells, so I will select the surfaces of each cell, create name selection. I will select cell boundary here. So this is inlet, this is outlet, and this is your cell boundary. So in addition to that, you may specify the casing also. So I will show all bodies, and on the channels I will make it hide all other bodies. So I may select all here and may specify this as casing. Okay, so here inlet, outlet, and then this is your casing, or you may say this is as a channel also over here. So inlet, outlet, cell boundary, casing. Even if it is not specified, still it is okay, but we can go with the casing also. So here I will may say here, instead of this I will make it channel casing. Make it update. So the mesh show all bodies. So this is channel, then fluid. Okay, so we have already done this. So we'll open the next part that is related to, so one more time I will click on update. So once this is done, you can just click on close meshing. Go to the workbench window again. Let's go to the setup. Use the number of processors you have. I am using 16 over here. If you want, you just close the geometry also. So channel is your solid, fluid is cell is again your solid, so you need to understand that. Now once the geometry is done, you can also close the geometry so as to have a better speed with the processor. So we have some inlet and outlet over here, so click on this transient, select the gravity, let's make it minus 9.81, make it minus 9.81. Okay, so go to the model, select energy equation, make it turn on over here, viscous, K epsilon, enhanced wall treatment, thermal effect, curvature correction here. Then go to the materials, so select the materials. So from the Fluent database I am using water liquid as a working fluid over here, so make it copy, then close, then close. For solid we are using two. One, it is the cell material is actually nickel, so I will put it solid, so nickel, I make it close. Casing will keep it aluminum only, so we're not going to make changes to that. So cell zone condition, put cell. What is cell? It is a solid, so it is made up of, say, nickel, the outer cover. So close this. Then channel will be by default it is aluminum, so I will keep it as it is, no changes to this. Fluid, I will make it water liquid, because there are two options, air and water liquid, so I will make it water liquid available here, and close. So cell zone conditions are done. Now it's time to put boundary conditions. So at inlet I will put some velocity, so let's take it around 2 meter per second as a velocity, make it apply, and then close. Cell boundary contact region is where we are going to apply the boundary condition. If you are confused with where is the cell boundary contact region, you just click on the individual thing, so you can see these are all cell boundary contact regions are there. This is the second one, so all these places we need to apply the boundary conditions, so accordingly we'll proceed. So let's see this one, what is this? Okay, so this is how the channel casings are been there. So on this we need to apply the we can say boundary conditions. So cell boundary contact region, so this is the first place where we are going to put some values of temperature. So let's take temperature, let us say is equal to 323 Kelvin, so it is around 50 degrees Celsius. Make it apply, then close. Cell boundary contact region, sorry, make it edit, so temperature is 323 Kelvin, make it nickel over here, make it apply, close, make it apply, and close. Again wall cell we need to apply the boundary condition, that is the last part. Here nickel, temperature will be 323 Kelvin, make it apply, close. Over here inlet we already put the boundary condition, that is 2 meter per second, so accordingly we are going to proceed. So next thing is reference values. Tell the computer from where to start. Let's say it is to start from inlet. Reference zone will select as a fluid here, then go to the report definition. So I just want to see how the variations are there in the temperature, so I will put it temperature, and since I will take it total temperature. Where I want to visualize, I want to visualize at the outlet, so print to console and print to output parameter, make it okay, and then close. In addition, if you want some different parameter, so you can add that also. Then go to the initialization. Again we need to tell the computer from where to start. We need to start it from inlet. Here click on initialize. Go to the calculation activities, click on autosave after 20 iterations, then go to the solution animation, go to the contours, and instead of pressure I want temperature, so I want total temperature over here, so select all, then color map option, I will take its float so that exponential scale will not be there. Make it save display, then close, select the contour one and make it okay. So here the scale is not exponential, so that's why we have selected the float option available. Keep it fixed, make it, let's say, 10 first, and let's click on calculate. Just observe the images, how the color contours shows. If there are some any issues, you can just that's why I took the very small time number of time steps, that is 10 only. So if there are some any problem, we can again go back and do some modification if it is required. So one scale residual which will show you the number of iterations which have been performed. One more window that will open is the contours of temperature, that is total temperature we have set. Another window that will be there is the outlet temperature, how the outlet temperature is being varying, so that is also we are going to visualize. So it will take some time to load the temperature window. So you can see the color contours. So we'll run the simulation for some long time, and then we'll check out how the things are taking place and how it is been visualized in the post processor. So we'll have to run it maybe around higher flow time. So this is how the plot which is there for outlet temperature, how outlet temperature has varied. It has increased over here around the flow time. So this is, we have run it around 10 time steps, so we'll definitely run it for more. So let's let it for 100 and just we'll wait how the simulation comes out. So for this we need to save it again. Okay, so once it is saved, again you can start with the calculation.